From the first steps on the moon to rovers on Mars, humanity's journey to the stars has been one of constant innovation. But buckle up, space enthusiasts, because you ain't seen nothing yet. Welcome to a countdown of 18 mind-blowing space technologies that are about to change everything. Remember when rockets were one and done? Those days are over. Reusable rockets are revolutionizing space access, slashing launch costs, and opening up new possibilities for space exploration and commerce. By recovering and refurbishing rockets, companies like SpaceX and Blue Origin have cut launch costs by up to 30%. Imagine buying a plane ticket, then watching the airline throw away the entire aircraft after one flight. That's how space travel used to work. Not anymore. As reusable rocket technology improves, we could see a future where launching into space is as routine as catching a flight. We can get away to the moon, anyone? Imagine harnessing the power of the sun 24/7, unobstructed by clouds, atmosphere, or nighttime. That's the promise of space-based solar power. The concept is simple but revolutionary. Giant solar arrays in orbit collect sunlight continuously, convert it to microwaves or lasers, and beam it down to receiver stations on Earth. It's clean, constant, and potentially unlimited energy. While the initial setup costs are high, this technology could provide a constant source of clean energy to even the most remote areas on Earth. It might just be the key to solving our energy crisis and combating climate change. When we finally set foot on Mars, we'll need a place to live. But shipping building materials across millions of miles of space? Not exactly cost-effective. Enter 3D printing, using Martian regolith. That's a fancy word for Martian dirt. As the primary building material, large-scale 3D printers could construct habitats before human astronauts even arrive. NASA's already running competitions to design these future Martian homes. These aren't just simple shelters. We're talking complex structures with radiation shielding, temperature regulation, and even separate living and working spaces. It's not just a habitat, it's a home away from home, about 140 million miles away. Quantum physics might seem like magic, but it's about to make our communications super secure. Welcome to the world of quantum communication satellites. In 2016, China launched Mischius, the world's first quantum communication satellite. It uses a mind-bending phenomenon called quantum entanglement to create unbreakable encryption keys. Here's the cool part. If anyone tries to intercept the communication, the very act of observing it changes it. It's like a letter that self-destructs if anyone but the intended recipient opens it. This technology could make hacking a thing of the past. Think of asteroids as the floating treasure chests of space. They're packed with valuable metals and minerals, some of which are becoming scarce on Earth. We're talking platinum, gold, and rare earth elements crucial for electronics. A single asteroid could be worth billions or even trillions of dollars. But it's not just about getting rich quick. Asteroid mining could provide the resources we need for large-scale space construction and fuel production, without the environmental impact of Earth-based mining. It's a game-changer for sustainable space exploration. If we want to send humans to Mars and beyond, we need to get there faster. Enter nuclear thermal propulsion, the hot rod of space travel. Unlike chemical rockets, nuclear thermal rockets use a nuclear reactor to heat propellant to extreme temperatures. This results in exhaust velocities twice that of the best chemical rockets. What does this mean? We could potentially cut the travel time to Mars in half. Less time in space means less radiation exposure for astronauts and less chance of something going wrong. It's safer, faster, and more efficient. Living in space means dealing with tight quarters. But what if we could pack an entire space station into a relatively small rocket? That's the promise of inflatable space habitats. These habitats are launched deflated, then blown up like a balloon once in orbit. Don't let the word inflatable fool you. These structures are tough. They're made of multiple layers of fabric and protective materials, potentially offering better radiation shielding than traditional rigid modules. Companies like Bigelow Aerospace are already testing this technology on the International Space Station. In the future, we might see entire space hotels or lunar bases built using this technology. Talk about a room with a view. Imagine stepping into an elevator on Earth and stepping out in space. That's the dream of the space elevator, a concept that could revolutionize our access to orbit. The idea is to have a cable anchored to Earth and extending beyond geostationary orbit, with a counterweight at the far end. Electric cars would climb up and down this cable, lifting people and cargo into space without rockets. The main challenge? Building a cable strong enough and light enough to withstand the immense stresses involved. But with advancements in materials like carbon nanotubes, we're getting closer to making this sci-fi concept a reality. Forget chemical rockets. The future of space propulsion might be as simple as shining a really powerful laser. The concept is straightforward. A powerful ground-based or space-based laser array focuses its beam on a spacecraft equipped with a light sail. The photons from the laser transfer their momentum to the sail, accelerating the craft. The best part? With no need to carry fuel, spacecraft could potentially reach a fraction of the speed of light. We're talking about the possibility of interstellar travel within a human lifetime. Proxima Centauri, here we come. Floating in zero-G might look fun, but long-term exposure can wreak havoc on the human body. Enter artificial gravity, the key to making long-duration space missions feasible. The most promising method involves rotation. By spinning a spacecraft or space station, we can create a centrifugal force that mimics gravity. It's the same principle that keeps water in a bucket when you swing it over your head. With artificial gravity, astronauts could maintain bone density, muscle mass, and cardiovascular health during long journeys. It's not just about comfort. It's about making Mars missions and beyond possible. Today's spacesuits are marvels of engineering, but tomorrow's will make them look like medieval armor in comparison. We're talking self-healing materials that can seal punctures automatically, built-in power generation through movement, and augmented reality displays in the helmet. Some designs even propose a second skin approach, using mechanical counterpressure instead of gas pressure. These suits won't just keep astronauts alive. They'll be like personal spaceships, enhancing strength, endurance, and sensory perception. Exploring alien worlds just got a whole lot cooler. Why carry everything you need when you can make it on-site? That's the idea behind in-situ resource utilization, or ISRU. Take Mars, for example. Its atmosphere is 96% carbon dioxide. With the right equipment, we can break that down into oxygen for breathing and carbon for manufacturing. The soil contains water ice we can extract. It's like a Martian hardware store. ISRU could allow us to produce fuel, building materials, and even food on other worlds. It's not just convenient, it's essential for sustainable space exploration and colonization. Chemical rockets are so last century. The future of space propulsion might lie in the fourth state of matter, plasma. Plasma engines, like the VASM Variable Specific Impulse Magnetoplasma rocket, use powerful electromagnetic fields to heat and accelerate plasma to incredible speeds. They're like the Teslas of spacecraft propulsion, all electric, highly efficient, and seriously fast. While they don't provide the quick burst of acceleration that chemical rockets do, plasma engines can operate continuously for months or even years. This makes them ideal for cargo missions to Mars or asteroid belt exploration. Houston, we have a trash problem. With over 500,000 pieces of debris orbiting Earth, space junk is a serious threat to satellites and spacecraft. Engineers are developing various solutions. Giant nets to catch debris, harpoons to spear it, even lasers to zap it out of orbit. One cool concept involves using electrically charged tethers to slow down debris, causing it to fall into the atmosphere and burn up. Cleaning up our space environment isn't just about tidying up. It's crucial for the future of space exploration and satellite operations. It's time for some cosmic spring cleaning. Why send one big, expensive robot when you can send a swarm of small, cheap ones? That's the thinking behind robotic swarms for space exploration. Imagine hundreds of smartphone-sized robots working together to explore a planet's surface, construct structures, or even self-assemble into larger machines. If a few get damaged, no problem. The swarm adapts and carries on. These swarms could go where traditional rovers can't, exploring cave systems, scaling cliffs, or even diving into alien oceans. It's like having a whole army of tiny astronauts at our disposal. If we're going to live on other planets, we need to grow food there. But space isn't exactly farmland. That's where bioengineered plants come in. Scientists are working on creating plants that can thrive in low gravity, tolerate high radiation, and grow with minimal water and soil. We're talking super efficient, ultra-hardy space crops. Some concepts even include bioluminescent plants to provide lighting in space habitats. Imagine a garden that's also a light source. Talk about a green solution. If you thought nuclear propulsion was powerful, wait till you hear about antimatter engines. This is the holy grail of space propulsion. When matter and antimatter collide, they annihilate each other, releasing enormous amounts of energy. We're talking about 90% energy efficiency compared to chemical rockets' measly 1%. With antimatter propulsion, we could potentially reach a tenth of the speed of light. That means reaching Mars in days instead of months, and making interstellar travel a real possibility. The catch: creating and storing antimatter is incredibly challenging and expensive for now. Our final technology takes us beyond our solar system. Interstellar light sails could be our ticket to the stars. These ultra-thin, ultra-reflective sails would be propelled by the pressure of light itself, either from our sun or from powerful lasers. No fuel required, just the power of photons. The Breakthrough Starshot project aims to send tiny probes with light sails to Alpha Centauri. Their goal? Reaching 20% of the speed of light. At that speed, we could get pictures from another star system within our lifetime. And there you have it, 18 mind-blowing space technologies that are shaping the future of space exploration and potentially changing life as we know it. From reusable rockets making space more accessible, to antimatter engines and light sails promising interstellar travel, we're entering a new golden age of space technology. These aren't just flights of fancy. Many of these technologies are already in development or early testing. They represent humanity's boundless creativity and our relentless drive to explore the unknown. Which of these technologies excites you the most? Which do you think will have the biggest impact on our future? Let us know in the comments below. And if you're as thrilled about the future of space exploration as we are, hit that like button and subscribe for more cosmic content. Remember, the sky is not the limit. It's just the beginning. Until next time, keep looking up and dreaming big.